Hello and welcome to another video in this series looking at how to achieve structural steel design using AI and retrieval augmented generation. In this video I compare the performance of the latest open source LLMs from USA and China, Nemotron 3 Ultra 550B and Xiorg GLM 5.2 753B. I tasked the LLMs to solve all 168 of the structural steel design examples in the AISC 36022, companion to the AISC Steel Construction Manual, Volume 1, Design Examples, Version 16. In a previous video I tasked Claude Fable 5 to the same task, and you can see that video for Fable's results. In this video I will discuss the open source results. Both reports are on my website at steelcoldform.com. Each design was compared to the verified solutions database, on the key numerical values, the structural adequacy checks, and the member or connection sizes, and marked as matching the solution a different but safe design or an unsafe one. An unsafe design selects a member or connection that differs from the solution and is non-conservative. A safe but not matching design differs in some numbers but selects a member or connection that is the same or more conservative. Matching and different but safe designs were aggregated into the safe designs category. Across the 168 designs, GLM 5.2 comes out ahead at a 94% safe rate, 132 matching, 26 conservative, 10 unsafe, against Nemotron 3's 92.3%, 119 matching, 36 conservative, 13 unsafe. Of the 17 designs unsafe for at least one model, 6 were unsafe for both, a shared hard core that accounts for most of GLM 5.2's failures and nearly half of Nemotron 3's. Stability bracing in Appendix 6 was the worst chapter for each, 3 of 6 unsafe for Nemotron 3, 2 of 6 for GLM 5.2, while Nemotron 3's other failures cluster in the part IIA connections and GLM 5.2's inflexure. The shear, combined force, bolt and weld, and HSS chapters were clean for both. The 6 shared misses were mostly undersized members, stability braces, a tension member and an angle 1 or more sizes light, and a far too light composite beam, plus a shear end plate whose integrity strength both overstated by about 2.5 times. Nemotron 3 missed 7 more. A halved bracing demand, a second-order moment understated roughly 18-fold, a lighter flexural section, an undersized bearing plate, an overstated connection tie strength, an extended single-plate passed where the verified rejects it, and one question left with no design at all. GLM 5.2 missed 4 more, all but one a member size slightly light, a column, an HSS, and a round bar, plus one overstated tie strength. Weighing severity, many were marginal, a single size or increment light, and given the conservatism of the steel specification we wouldn't be overly concerned. GLM 5.2 badly missed 5 of the 168, 3%, Nemotron 3 badly missed about 8, 4.8% plus the one non-answer. On the serious errors too, GLM 5.2 is the safer of the two. After that, there is a question-by-question comparison you can read for yourself on the web page. As mentioned, Fable 5 completed this task in a previous video, and the results are compared with the open source models here. Notably, Fable 5 had the highest accuracy and the fastest compute time, however was about 10 times more expensive. GLM 5.2 had slightly less accuracy, however was very slow to complete the 168 designs. Nemotron 3 took 7 hours, was the cheapest by far, however had the lowest accuracy and also had the most bad misses. Note that Nemotron 3 NVFP4 was used, and FP16 may have done slightly better, however I had problems running this version via Hugging Face.